Welcome and thank you for joining this session. My name is John Jackson, and today we're going to be talking about creating data pipelines with Amazon Managed Workflows for Apache Airflow. This session is for anyone who's interested in Apache Airflow or data pipelines and workflows in general. Whether you're new to Airflow and want to learn what AWS has to make it easier to get started, or new to AWS and want to learn more about our workflow tools, or if you're experienced with Airflow and you want to hear how Managed Workflows makes Apache Airflow easier to deploy, maintain, and scale. So we're going to start out talking about the general data pipeline problems. And for you data engineers and data scientists in the crowd, this is going to be very high level, but it sort of set the stage as to why Airflow is so important. I'm then going to introduce Airflow itself and explain to you some of the main components and benefits and challenges that it introduces, again, at a very high level if you're experienced with Airflow. After this, I'm going to introduce Amazon Managed Workflows for Apache Airflow, or MWAA, and how it works and what benefits it provides. I'll then give you a quick demonstration of how to build a very rudimentary data pipeline with Amazon MWAA. And then we're going to discuss a little bit about how Amazon MWAA works with integrations and open source, and when to choose it for your orchestration needs. So, why should we be interested in data pipelines in general? Well, many organizations have built their entire business around data. And in order to benefit from that data, you have to take it from where it was produced and move it to where it can be used. And that's the basic definition of a data pipeline. Data pipelines, that general movement of data, have become more complicated over time. So for example, movie studios used to be able to track their sales by counting the number of physical DVDs produced. And if you're a little older like I am, VHS and maybe even Betamax too. The data pipeline was very simple. There was the number produced minus the number in the warehouse, and that's how many sales there were. And since the studios controlled most of this process, analysis was easy. You might add a little bit extra for in-theater movies, but other than that, that's about it. But now, studios have to track sales of not just physical items and theater tickets sold, but pull out digital sales and online rentals. They have to track stream counts from a variety of different sources. There's also social media and broadcast campaign and marketing campaigns to track and correlate with those effects on those sales, rentals, and tickets. And each of these services typically exposes an API or some other shared data source. And these APIs are all different. Sometimes they may not be accessible, and when they are, the format may not be exactly in the way you want it, and it needs to be manipulated so it can be actually used. Sometimes even the content of the data isn't exactly correct. For example, some services may list a movie as the blank versus other ones that use blank, comma, the. So let's take a look at how even a simple version of this use case can be complicated. So the way this data is managed is through a series of tasks called a workflow. And this type of workflow is going to be constructed in such a way that certain tasks need to finish before the next task can begin. So for example, we may want to make sure all the data has been pulled from all the different streams and rentals and purchases before we try and merge it together. And we want to make sure that we do all this in a certain order without going back. So this type of workflow is called a directed acyclic graph, or DAG. So in our case, the DAG workflow will start by connecting each service, requesting the play counts and the views and that sort of information. And then after that, we're going to have to process the data. We might send it to EMR or maybe an ECS container or EKS and convert it into, say, let's convert it from a CSV to a Parquet format, or maybe fix those titles. After we do all that data processing, maybe we'll send it to something like Glue or Athena to do analytics, or maybe something like SageMaker that can actually extract out additional information that can be combined. And then after all this is done and we have a clean data set, we'll want to upload this information to something like Redshift for further analysis or DynamoDB for storage. And if there's a failure anywhere along the way, we're going to want to be able to resume just from that point, because any of these tasks might take quite a bit of time, and we're not going to want to have to go back and restart them all. So Apache Airflow has emerged as a fantastic tool to be able to manage this sort of data pipeline. It lets us define the flow from a selection of hundreds of built-in operators and community-created plugins, including integration to 16 different AWS services, third-party tools such as Apache Spark and Hadoop. And Apache Airflow has a very active open source community, so fixes and features happen on a regular basis, and there's always plenty of places to go to get help. So in Airflow, we define these DAGs in Python. And then we can see here how that previous workflow we just showed you would be reproduced in the Airflow as one of these Python DAGs and then displayed in the user interface. So assuming that we didn't cover your exact use case, why would you be interested in Apache Airflow? Well, there's three main sort of categories of use cases. The first and by far the most common is ETL, or extract, transform, load. This is what almost all installations of Airflow do at least sometimes, and that is really that facilitating that data pipeline, that movement of data. An emerging area is around AI ML, or artificial intelligence machine learning. And really this has to do with just the sheer volume of data you have to pre-process to do this. So let's say, for example, you're creating a pipeline for autonomous vehicles, right? So when the car comes into the garage, you have to then offload all of that data from the vehicle and get it to a source where it can be used for your machine learning models. But each vehicle might have a slightly different camera system or LiDAR, and all this data has to be normalized, and the camera color space needs to be modified so that it can actually properly be analyzed by something like SageMaker. And then the third category for Airflow is really around DevOps and IT operations. And these are a great fit for Airflow because Airflow is very flexible. It can streamline and automate day-to-day tasks. And in fact, plenty of customers actually use Airflow to manage Airflow. For example, keep maintaining the metadatabase that Airflow uses and keeping only a certain amount of data, historical data. So speaking of that metadatabase, what are the Airflow components? And again, for those of you that know Airflow, this is going to be really obvious for you. But just for anyone else, there's four main components to Airflow. There's the scheduler, which not surprisingly schedules the work, and the worker that not surprisingly does the work. You then have a web server component that lets you access that user interface like what you saw earlier. And then there's a metadata base that I just referred to, which really stores all of the state information and all the historical tasks. But there's a number of challenges around self-managing Airflow. The first is really just around that setup. It's typically a very manual process, so much so that some customers end up developing their own tooling around it. Scaling can be a challenge. You can do this with EC2 autoscaling or Kubernetes, but these have their own complexity they bring into the mix. For security, often supporting role-based authorization and authentication can be a little challenging with Airflow. You often have to authenticate in one place and then have the user log into the Airflow user interface to give them a proper authorization role. Upgrades and patches can be challenging. Sometimes there'll be a breaking change in an upgrade, and just maintaining the hundreds of libraries and dependencies that Airflow needs can also be a challenge as well. And then finally, there's that ongoing maintenance. Airflow is running arbitrary Python code. It can crash. It can have issues with it. And being able to know there's a failure and recover from a failure is super important, especially in a production system. So listening to the customer demand around these challenges, AWS has released Amazon Managed Workflows for Apache Airflow. And this was really built to address these challenges I just mentioned and still providing everything great that Airflow has to offer. So first and foremost is setup. Now, Amazon MWAA is not a branch of Airflow we're just compatible with. We're actually running the exact same open source Airflow software that you can download and run today. We've just made it a little easier to work with. It's got the same same great user interface, and we've also made it really easy to stand up new environments, either from the AWS console, command line interface, API, or CloudFormation. We've also made scaling easy. So really what we do is we monitor those queues of tasks, and when we see that you need additional capacity, we'll add additional containers. This is all running on the back end using Amazon ECS on AWS Fargate, so it's very easy for us to bring up other containers. And it's also using a Celery executor, so it lets you control the parallelism and how many tasks actually run per container. For security, we have full integration to IAM for both authentication and authorization, which means that you can provision your users to be able to access the UI, not just that they have the access to it, but what they're actually allowed to do when they get there. So for example, I may have a developer role or a developer group that I want to give them full administration or ops privileges on dev systems, but I only want them to have view-only access on production systems. That gives them access to that Airflow UI, and that user interface can be either connected through a VPC endpoint into your virtual private cloud, we'll talk to that in a second, or we can provide a URL whereby you can actually access it directly from the internet Again, still secured by IAM. Speaking of IAM, the workers actually assume an IAM authentication role, or execution role, excuse me. And this simplifies access to AWS services. So if I want to give a given Airflow environment access to EMR, I simply give that particular environment's worker execution role the ability to access my EMR cluster, and away it goes. And the workers and scheduler run in your VPC, which means any assets that perhaps live on-prem or are connected to other secured assets, as long as they're accessible from the VPC you've attached to the workers, then they'll be accessible from Airflow. Around upgrades, what we've done is we allow you to designate a maintenance window. And this is when we'll do any patching that needs to be done for security fixes and things like that. But it's also when we will perform any upgrades that are needed. And then if there is any issues, we'll allow you to roll back from that upgrade as well. And finally, around maintenance, we have integrated monitoring with Amazon CloudWatch. So it makes it very easy to monitor one or more environments centrally and create alarms and alerts. As I mentioned, it's running on Fargate, so therefore it's by nature a multi-availability zone. And so therefore at any failures or if there's any unhealthy containers, we swap those out on your behalf. And then we'll also automatically be able to restart on any failures that occur. So how does it work? Well, it's actually fairly simple. We create a MWAA environment, which is really just that open source version of Airflow, with all of the connections and wiring and everything else you need to actually make it work. You then simply provide these directed acyclic graph Python codes, or DAGs, into a folder in an S3 bucket that you designate. And then we'll take care of making sure that any containers that are being used get updated with those DAGs. And then after that, you're just accessing the Airflow UI, as I mentioned, either right from a URL or through a VPC endpoint. So to give you an idea of what this looks like, for those of you that want to understand how this is put together, you can see how that within your VPC, the Airflow scheduler exists, and then one or more Airflow workers, depending on how many you need based on your demand. And then within the services VPC, we have a metadata database, and then the Airflow web server, which can be connected either to that aforementioned VPC via a VPC endpoint, or accessible via the internet via a internal to the service application load balancer. And in either way, those are secured by IAM. So I'd like to now walk you through what this looks like, and this is live on the console today. You can try it out right after this session if you'd like, or you can play along while we go if you'd like. So here's the landing page for the service, and you can see here how we describe the environment, we describe what it looks like, and then clicking on the big orange Create Environment button, we'll start out with just a brief description of what this looks like. So I'm going to go through and give my environment a name so that we can actually designate what it's actually called. And I'll just call it a demo, MWAA demo. You can see here also where we can specify the specific Airflow version we want to use. So in this case, this was actually the latest version as of release. When we verify the next release, which is 1.10.13, and we validated that it's safe to use, you'll be able to designate that as the new version, and we'll be able to upgrade that in the maintenance window, as I mentioned. So from here, if we scroll down, you can see we can go down and get down to the where we designate the S3 bucket. And there's a couple of requirements around the bucket. One is it has to be prefixed with Airflow dash. The reason for this is that the Airflow environment has full access to this particular bucket. So this is a way of basically designating that we acknowledge that this bucket is used for this environment, and it's not being used for sort of general Airflow or general S3 storage. And then the other requirement is actually around versioning. I'll mention in a second. So we actually provide a link right here. If you don't have a bucket and it's in the right format, you can click there. It'll open up the S3 console, and you can create a bucket in that respect. In this case, I do have one that has the proper Airflow prefix, so I'm going to go ahead and choose that. And one thing to make sure you note that if you're pasting in your S3 bucket, you need to make sure you don't have a trailing slash on this, that it just has the bucket name with the S3 prefix. After this, we're going to need to go and select a DAG folder. This is where those Python workflows actually live. So you can have a single S3 bucket that has many different folders for different environments, or you can have one environment per bucket. In addition to this, we also support plugins and requirements. So the plugins are just the same Airflow requirements or Airflow plugins that you can put in today. And you just simply zip those up. And the reason for that is twofold. One is that we don't want to get into a race condition, so we want to make sure that all those plugins get loaded at once. And the other reason is that the bucket supports versioning, so that we can make sure we can roll back. And same for any of those Python requirements. So the next thing, as I mentioned, was that the scheduler and the workers live within your virtual private cloud. So of course, you're going to need to pick that. Now, there's a couple of requirements around this. One is that you must have private subnets within your VPC that connect and are able to connect to the internet on the public side. So if you don't have a VPC that supports that, we do have a quick link to be able to quick create one in CloudFormation. But you can see here I have one set up, and you can see that they just automatically selected the multi-availability zone subnets. You then need to pick whether you want to have the web server terminate in a private endpoint within your VPC, in which case you'll need to do some additional setup like a NAT or a Linux Bastion. Or you can select a public network, in which case it's provided just by you access via URL. And either way, you authorize that connectivity via IAM. Now, it also requires a security group, so we can create that for you, or if you already have one configured, that can be selected here as well. You then need to pick an environment size. So Airflow 1.x has a limitation that there's only one scheduler per environment, and that really defines the number of workflows that you can concurrently load into memory. And so a small environment, in our testing, it's roughly about 50 workflows. Now, if you have a single workflow that loads 1,000 sub-workflows, of course, that would throw that off. But we do have the ability to change this after the fact, too. And of course, some of those metrics, I'll show you in a second, will help with that. The other thing you define on here is the maximum number of workers. And this really is sort of a cost control measure, because we'll scale out the workers to meet the parallel executions you need up to whatever this maximum is you define here. And then after that, Airflow's typical queuing mechanism kicks in. When there are no more tasks in the queue and no more tasks executing, we're going to dispose of all those extra workers, and you'll be back down to that original worker that you had. So we have, as I mentioned, integration to CloudWatch. This is for all the Airflow metrics, plus the task logs. So this is the actual logs from those executions, and optionally the rest of the logs as well. And we support things like the Airflow config options and other elements like that. Finally, we can either create or select an execution role, and this is the role that actually determines what it's able to do what this environment's allowed to connect to within the AWS ecosystem. So after that, we hit Create Environment, the big orange button, and then we give it a few moments, and it'll kick us over to the List Environments page, where it'll actually show us which environments are available. So this process does take a few minutes. It's building the database, it's building the containers. So you can see here it says it takes about 20 minutes or so. So rather than wait for this one to build, we're going to go ahead and connect to one that I already had pre-existing. And you can see here it just provides a list. This is everything you'll see for your Airflow environment. So when I wish to access it, I'm just going to go over to the right-hand side and where it says Open Airflow UI, and that will connect me directly to the Airflow instance that we've just set up. So once we've done this, we're just now in Airflow. There's nothing unique about this other than integrating to IAM for their authorization. So now we need to provide an actual workflow. So I've created a very simple DAG here. All it's going to do is it's going to use a Python operator, an S3 sensor, and an S3 hook to go ahead and see if a file shows up into S3. And when it does show up there, I'm going to do a very simple transform on it with Python, and I'm going to return it back to that same S3 bucket. So here's the transform I built. Super simple. I'm using the S3 hook, which is one of the built-in Airflow capabilities. I'm going to go through and pull the input file out of that, the input key. I'm going to remove all the double quotes from that in a file, and then I'm going to return it back to S3. And you can see here I've defined the bucket and the input key and the output key as part of this. To actually define how these work together, you can see here I've defined a DAG. I'm just calling it copy S3 file. There's that Python operator that's going to call that function we just did. And then you can see right above it is the S3 key sensor that actually is going to wait until that key is available for the input file. After that, we just simply connected it via the two sort of greater than signs, and away it goes. So I'm going to copy that up to the S3 bucket. But there is one more thing I need to do is when we create the environment, it's only has the ability to read these DAG files and the Python files and things like that. You can see it refreshed, it came up. But I do need to give our worker the ability to write to this S3 bucket. So if I go look at the environment details page and I scroll down to the bottom, it gives me a link to the in IAM to the execution role. So I'm going to click on that. And what I'm going to do here is I'm going to do it in a very simple way. I'm just going to go ahead and give this particular role just access to all S3 buckets. Of course, in production, you would have it limited to just the scope it needed, but this is just simply for demonstration purposes. So I'll just give it full S3 full access. And then going back to the user interface, I can go now click on this workflow, and it has everything it needs to run. So you can see here's those two steps that we defined in the DAG file. I'm going to go to trigger DAG, and I'm going to go launch it. And of course, this could also be on a schedule as well. That's the typical way to run these. And then I'm going to go through, and you can see the different state. So I can actually click on each of these tasks, and I can click on view log, and it will show me what the current output is from this. So if I scroll to the bottom, we can see it's waiting for that input key that we defined in the DAG file. So let's go ahead and provide that key so it's able to actually perform the task. So it's waiting for this key to show up. I'm going to go ahead and copy this to my S3 bucket as well. And I'm just going to use the CLI command. I'm going to copy the CSV file name. And I'm going to go back and copy the target file. It happens to be just in the log, so I'll grab it from there. And I'll hit go. So now, this S3 sensor, if I refresh it, it's going to, once it sees that file is there, we're going to see a success on that. So now I can go through and say, okay, well, let's go see how the rest of that workflow is working, because we've got the key now. So it should launch that Python function that's going to transform it. And you can see it's already completed. So again, I can click on the actual task, click on the view log button, and we can see here that at the bottom it shows success. It was able to do what we asked it to do. So let's go back to that S3 bucket and make sure to see if that target file is actually there. Now, since I used the same bucket as I was using for the test, it's in the same file. I can go through and click on the CSV file, and let's just open it up. And here's the file we just created. You can see it's the exact same CSV file I loaded, except now it's missing the two quotes. So obviously this is a super simple example, but these are the basic building blocks to be able to generate whatever data pipeline you actually need to do. So going back to the console, one other thing we can do here is go look at how these logs are actually sent to CloudWatch. So as I mentioned, all of the metrics and logs that you choose are sent to CloudWatch under the name. We can actually see here's that demo environment. And if I click on the task logs, then we can actually see exactly what it's reported. We can see all the information, and we can create alerts. Let's say I want to create an alarm on if there's a ton of exceptions or anything like that as well. And that's the basic building blocks of our managed Airflow service. So let's talk about these integrations. Integrating is very easy. As you saw, integrating to AWS services, since we're running the open source version of Airflow, that comes with 16 existing integrations, everything from DynamoDB, EMR, EKS, SageMaker, you name it. There's also tons of container support built in. So the ECS operator, the Kubernetes pod operator, and the Docker operator are examples of those to integrate to containerized workloads. And then, of course, there's hundreds of built-in and community-created operators, and sensors, and plugins to be able to handle a bunch of other needs. One thing I wanted to make sure I stress is that we are committed to supporting solely the open source version of Airflow. So any improvements we make, we will go first through the open source submittal process and make sure that they are accepted by the community before we adopt them in a version. We're not going to branch or come up with our own version. We're dependent on Airflow being healthy, and whether you run our managed service or not, we want it to be a great service for everyone that uses it. So talking a little bit around when to choose Amazon MWAA versus some other offerings on AWS. A natural comparison would be step functions, which is another orchestration platform. Really, MWAA is really about when you are either committed to open source, or you have a lot of non-AWS resources, or you have a lot of customization you want to do for things that are perhaps on-premise. Whereas step function is fantastic for very much for high volume loads, and it really provides a high volume orchestration at a low cost. So why would you choose Amazon MWAA for your Airflow needs? Well, first and foremost, it's easy. As you saw there, setting it up is very straightforward. It's all done through the console or through CLI or API or CloudFormation. And when you create these, it's secure by default. But it's still familiar. It's still that Airflow interface that you know and love, and you can still enjoy it the way you want to enjoy it, but now with the great AWS experience. And finally, it's robust. We handle the scaling for you without any configuration. We'll patch it, we'll provide the monitoring integration, and we make it easy to handle those upgrades. So thank you very much for your time in this session. If you want to reach me, my information is here on the screen. You can reach me on Twitter or send me an email. Happy to hear from all of you. And please don't forget to complete the session survey. That's how we know if we've done well and we were able to give you the information you're looking for. So once again, thank you very much and have a great day.